Hello everyone, you're welcome back again. We're going to solve for the value of k from this exponential equation. We call this exponential equation because the variable we're looking for appear as an exponent. So we're given 4 to power k plus 4 to power k plus 4 to the power of k is equal to 40. Then we are asked to solve for the value of k that will satisfy this equation. What are we going to do? If you look at the left hand side of this equation, we notice that we are adding the same thing 3 times. So 4 to power k, 4 to power k, 4 to power k. So this is going to give us 3 of 4 raised to the power of k, which is going to be equal to 40 because they are 3 and the same. So now the next thing we are going to do, remember we are looking for the value of k and we have 3 here attached to 4 to the power of k. So we need to first eliminate this 3 by dividing both sides by 3. So we divide the left hand side by 3 and also the right hand side by 3. So that this 3 is going to eliminate this 3. So in the left hand side we are left with only 4 raised to the power of k, which is going to be equal to 40 over 3. Now, what are we going to do from here? If you look at the base here, we have 4, and here we have 40 over 3. There's no way we can make the base to be the same. So therefore, we are going to take the log of both sides to base of 10. So when we apply logarithm, so we're going to have what? Log of 4 raised to the power of k, which is going to be equal to log of 40 over 3. Now, the next thing we need to do is to recall power property of logarithm. This k is going to go back to multiply log, because when you have log of a term to the power is going to go back to multiply the log of that term. So when we do that, we're going to have k log of 4, that's k multiplied by log 4, which is going to be equal to log of 40 over 3. Now remember, what are we looking for? We are looking for the value of k. And here in the left hand side, we have log 4 attached to k. So what are we going to do to eliminate this log 4? Is by dividing both sides by log 4 in order so that we can be able to cancel out log 4. So when we apply that, we're going to have log of 4 over log of 4. So that this log 4 is going to cancel log 4. We're going to have k to be equal to log of 40 over 3, then everything all over log of 4. We have k to be equal to this, but we're not going to stop at here. We need to simplify to its lowest form. So when we do that, we're going to have k to be equal to, here we need to recall what we call division property of logarithm. When we have log of a over b, this is the same as what log of a minus log of b. So this is division property of logarithm. So we're going to apply this property to the numerator in the right hand side. We're going to have k to be equal to log of 40, as you can see here, minus log of 3. So this is equivalent to this by applying this property. Then everything all over log of 4. And what do you notice? If you look at this numerator, the operation that separates these two terms is subtraction, and they have the same denominator. So therefore, each term in the numerator can share the same denominator. So when we do that, we're going to have k to be equal to log of 4, log of 40 over log of 4 minus log of 3 over log of 4. Okay, so they share the same denominator. Now we're going to have what? We are going to simplify further. This 40, we need to break it down. 40 can also be written as 8 multiplied by 5. It's going to give us 40, right? So we're going to have k to be equal to log of, in place of this 40, we break it down as 8 multiple 5, then everything all over log of 4 minus, here we have log 3 over log 4. So we just copy log of 3 over log of 4. Now here we are going to apply multiplication property of logarithm. So this place is division. Multiplication is just the opposite of division. When you have division, we change it to minus. And when we have multiplication, like for instance, a multiplied by b is going to be plus. So in this case, we are going to have k to be equal to log of 8 plus then log of 5. Everything all over log of 4 minus log of 3 over log of 4. Now, what do we do next? As you can see, log 8 plus log 5, everything over log 4. Since the operation here is plus, so they are going to share the same denominator. So we're going to have k to be equal to log of 8 over log of 4 plus log of 5 over log of 4 minus log of 3 over log of 4. Now, we need to simplify further. This 8 can also be written as 2 raised to the power of 3, because when you multiply 2 by 2 in 3 places, it's going to give us 8. And 4 can also be written as what? 2 raised to the power of 2. It will give us 4 also. So we're going to break them. So we're going to have k to be equal to log of k. 8 now will be 2 raised to the power of 3. Then over log of 4 is the same as 2 raised to the power of 2 plus log of 5 over this 4 is also the same as 2 to power 2 minus log of 3 over log of 2 raised to the power of 2 in place of 4. Now we break everything down to the base of 2, right? So now we need to simplify further. Recall power property of logarithm. So when you have a power, it's going to go back to multiply the log, like the way we did here. As you can see, this power here, we go back to multiply log 4. So we're going to have what? K to be equal to, this 3 is going to come back, it's going to be 3 log of 2 over, also this 2 is going to come back, we are going to have 2 log of 2 minus, here we have log 5 over, 2 is going to come back, we have 2 log of 2 minus log of 3 over, this 2 is going to come back also, we have 2 log of 2. Now we need to simplify further again. As you can see, log 2 over log 2 is going to cancel. This is division. So we're going to have k to be equal to, here will remain only 3 over 2 minus, here we're going to factor out these 2. It's going to be 1 over 2 log of, we need to apply changing of base formula here. So log 5 over log 2 is the same as log of 5 to the base of 2. Then minus, here is plus rather. So this place is plus. Then this is minus. Minus what? Plus 1 over 2 log 5 to the base of 2 minus, also we need to factor out this 2 out. It's going to be what? 1 over 2. Then log 3 over log 2 is the same as log of 3 to the base of 2. So finally, as you can see, we have something in common. 3 over 2, 1 over 2, 1 over 2. So therefore, we can factor out 1 over 2 out. So we're going to have k to be equal to 1 over 2. Then we open bracket. 3 over 2 divided by 1 over 2, it will remain 3, because when you use this 3 to multiply this 1 over 2, we're going to get the first term. Then plus, this 1 over 2 is outside already, so it will remain only log of 5 to the base of 2 minus 1 over 2 is also outside already, it will remain log of 3 to the base of 2. So therefore, the value of k that satisfies this exponential equation is 1 over 2 into the bracket of 3 plus log 5 to base 2 minus log of 3 to the base of 2. Thank you for watching, and please don't forget to subscribe to my YouTube channel and also follow this page for more videos like this.